Good morning, ladies and gentlemen. Have a seat. STEM journals, please. I have not seen you this week, so we have two things that we need to do for our first 5. Our first one is math. So if you'll pull that out, please. We have a lot to cover for today, so have a seat. All right, let's take a look at our math minute number 4. When you are done with this, we are going to shift to looking at our sketching for today, and I'll discuss that in just a minute. And then we have to play catch up with our code.org lesson. If we get through with all that, then we will start shifting onto our projects that we usually start building and have been starting on up to today. Number 1, we've got a pattern, 1, 5, 9, 13. Good, sir. What is the next number in the sequence? 17. What's next? 20. 20 and 22?
No, 22, then 26.
Oh, 22 and then 26. Okay. 22 and 26. Ham? Go grab you a sucker. What answer did you get, sir?
I got
17.
21.
21.
And 25.
25. All right. Can somebody raise your hand? Go grab you a sucker. Can somebody raise your hand and tell me what is the pattern that we are noticing with this? So it's okay if we get some questions wrong, right, in math. It's understanding that if we get it wrong, why did we possibly get it wrong so we can learn from that mistake, right? I'm not saying he's necessarily wrong, but he got 17 correct, and I think he was on the right path. He may have just accidentally added incorrectly. We notice that? So what would be the pattern? You, sir? 4? What about 4? Excellent. So the next number, I'm adding a 4 more to the value, right? So 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13. Therefore, the next sequence should be 17, because that's 13 plus 4. 17 plus 4 is 21, not 22. And then 21 plus 4 is 25. If he did, which one did he get wrong? It was a 22. And then from there, was he on the correct pattern? 22 plus 4 is 26. So what do we probably think happened to that number? He accidentally added wrong, right? And so if we're not careful, our sequence then becomes completely messed up because one number further in the sequence just accidentally got wrong. Even though you were doing the right pattern, you just messed up early in the sequence. We track? So good job on catching that. Number 2, we have 10 minus 4 times 2. Good, sir. All right, number 3. Fairly quick and easy. 18 thirds. Yes, sir. 6. How do I write 6 as a fraction? 6 over 1. Very good. Because I have it written as a fraction, I tend to leave it in this class as a fraction just so I see the pattern. Sometimes the patterns are easier if they're in this form. But if you wrote it as a number 6, you are correct. Either way, it's the same number, just a different look to that number. Does that make sense? Okay. Awesome. Go grab your sucker. Any questions with that? Awesome. Go ahead and put that away. Let's go ahead and open up our sketching for today. All right. So up until this point, we have looked at our sketches for lines, right? We define different types of lines. Anybody tell me or remind me, if a line has a start and an end, it has a special name. What do we call it?
We call it a segment.
It's a segment. If a line has a start but no end. It goes on and on and on and on and on and on and on, like the song that doesn't end. It goes on and on, my friend. It is called a what? Somebody remember? Yes, sir? Array. Now, we also talked about a regular line, which means it has no start and no end. We also defined angles, right? We then took those lines and those angles and we made a 2D shape. What is a 2D shape where all sides are equal and all corners are 90 degrees? A square. Then we made not only a 2D square, but we also drew circle and a triangle, right? And we defined what an oval was, what a rectangle was, just so we understand what they look like. Then we shifted into 3D structures, right? So if I have a circle, and the circle has some shadow or textures to it, it gives it the impression that we are looking at a 3D shape, which is called a what? A sphere. And commonly, I don't say I'm going to go play basketball with a sphere. I call it a what? Basketball. I call it a basketball or a ball, right? A sphere is a ball. It's just a common word for a sphere, right? Why are we doing all these sketches to begin with? Okay? It does help us, but how? This is an engineering class, so why do I want us to understand how to draw things? Yeah, because if you can at least think about the idea that when I sketch it, I can usually draw you a picture of something better than me trying to write out a whole essay or a whole paragraph trying to explain it, right? Have y'all heard the phrase, a picture is worth 1,000 words? Okay, this is what we are starting to look at, and today I want you to draw 6 emojis. Pick any of the 6 emojis. However, when you draw the 6 emojis, I want you to pick an emoji that you have drawn, even if you make up your own emoji, and tell me, what is the purpose of an emoji? Why do I send them on a text message? What do they mean? It is an expression. It can be an expression of an action, a thought, an idea, an item, right? Like a thing. Literally, I can send an emoji of a house. I don't know exactly what that would mean, but maybe that means go home, right? But today, I want you to draw 6 emojis fairly quickly. And if I look at these emojis, what are the basic shapes that make up an emoji? Yeah, they're just circles within circles, or half circles, or half ovals, okay? I want you to label those 6 and tell me, what is the emotion, if I was to send this to somebody, what emotion would I be trying to explain to them? So, example, we've communicated 2 different types of emotions by only changing one structure. The same thing happens in our builds when we are working with our structures, right? If I change the structure even by one beam, that structure in itself can change what I am intending it to do or what it's going to function as. Does that track? So when we give words to our drawings, those words give us better understanding of them and meaning to the picture, which is what we call context, right? It is what we are calling context. Yes, sir. Yes, sir. Yes, ma'am.
Like one time when I texted and I was someone to be funny, I was crying at the same time and all laughing, and I said the crying emoji with the happy.
Exactly. And so sometimes what we try to do is we try to combine our emojis. Now, could I not just send a text message that says, I am so happy right now, I am crying for you? It is a lot of words for me just to send a quick, simple picture. And so, what we've been working on this class is drawing basic structures to understand now we are getting into complex shapes to communicate our ideas. Okay? Pictures are very useful in science. That is why y'all draw models, right? Like the water cycle. Okay? They're trying to help you imagine what is going on through a visual, through a picture, to communicate the thought. right? Instead of just talking about, well, water evaporates. When water evaporates, it goes up into the sky. While it's in the sky, the water condenses into a cloud. Once it condenses into a cloud, then it starts to precipitate. Precipitation looks like rain. When it falls out the sky, it hits the ground, then it's called runoff. Then we repeat that cycle over and over again, right? Without you drawing it and making an illustration of it, it becomes harder for us to imagine exactly what I just described. Does that track? Okay, so does everyone understand why we are working on now emojis? Yes. Okay, we will be working on more complex structures and more complex shapes to better help us communicate our ideas in the STEM class.
Used to emojis in that topic, it's kind of like sign language.
It is, sort of. I can understand why you made that connection. All right, so we have, up until this point on code.org, been working with Blockly coding, which is basically seeing patterns to get our character to follow our commands, right? Move forward, turn left. We worked on something called repetitions or loops, right? Move forward, turn left, do that 4 times. And now what we're working on, thank you for your sign out, is drawing with our character. All right, so we are doing art with code. But this art that we're doing is very simplistic art. Okay? The art that we're looking at is, can you get your character to leave a mark behind it as it moves in order to draw a specific shape? Right? Because this is exactly what we have done, is that we have talked about specific shapes. And now what you're trying to do is, I got him. Thank you. Is work with our character to get it to carry out a specific set of patterns. I am noticing a lot of us are using something that is just individual commands. Don't forget that we can look for patterns and repeat those patterns, right? That is what that pink repeat block or that loop block allows us to do, is repeat certain patterns. So I can repeat the pattern of a square because it's just move forward, turn, move forward, turn, move forward, turn, move forward, turn. I can't quite repeat that same thing for a rectangle. Hey, how many of you are noticing that there's also a command called jump?
Yeah.
What does the jump command do?
It makes you move forward, but it doesn't come.
Thank you. The jump command makes me move, but it doesn't leave a mark behind. Hey, for those of you that are done, I want you to start working on your 3D shape. What shape should we be working on building? The cube. So go ahead and head on back to the back once you're done with your artist and start working on our structure. Hey guys, watch your eyes. I am turning on the lights and some people are starting on their structures to build. You can grab those buckets and place them all up here. Hey, you can go work on your structure because you're on lesson 5. You can work on lesson 5 if you want, but you okay? Make sure your links look off. So read each side is 150, what you got. And then your turns, I think, are going to be 120. So, well, you made a cube. So far, you kind of have an open box. So you just need, a top. And that when you put a top on there, it will create the other thing. So you just need one more like connector there. Does it make any sense? So the thing we have to look at now is that we want to keep these wheels from creating drag or friction. Rubber against plastic makes it want to stop. Buckets up here in the front need to be put up. Check your area. Make sure there are no pieces. You got that wheel, sir? Excellent. Thank you. You got it, sir? All right. We did an excellent job today. So far, we finished our math for this week. We did our sketching. We did